All right, to finish up the study guide, we're going to finish our last two, which 31 has two parts. It has like an A part and a B part, and they're both piecewise functions. We have some steps that we followed in class, and the first step is highlight or mark on the x-axis by looking at your x's. And when I say look at your x's, I mean look at the domain. So when it says look at the x's, what number do you see? I hope that 3 jumps out at you and you see that 3 is a number that's going to separate the first piece of the function from the second piece of the function. So we're going to go to number 3 and we're going to draw or mark or highlight a little line. And this is going to be a line that's going to separate the first piece of the function from the second piece of the function. So we've done like the first step. The second step that I had on the board says do an x and a y table for each piece. So I'm going to come up here and I'm going to do an x and a y table for the first piece. I'm also going to do an x and a y table for the second piece. Again, the number that separates this piecewise function is the number 3. So I'm going to imagine a number line 3, and the first one says if x's are less than 3. So if I think of numbers less than 3, I'm thinking about 3, so 3 definitely needs to go in my table. And when I put 3 in there, I'm going to think about 2, 1, and 0. I'm going to do a couple of numbers that are behind 3. 2 or 3 numbers is fine. So I'm now going to find my y's. Now, how do I find my y's? I'm going to take each of these x numbers that I have chosen, the numbers that I looked at on my number line, and I'm going to imagine putting them into the function. So this is the function. I'm going to put them here in place of the x. So that's going to be like negative 2 times the x value of 3 plus 3. So negative 2 times 3 is negative 6. Negative 6 plus 3 is negative 3. So the y value that goes with positive 3 is negative 3. All right. Next one. I'm going to do the same thing with 2. 2 goes into the y function in place of my x. So now it's going to be negative 2 there. Now I'm going to put my 2 here in the x place of the x plus 3. That's negative 4 plus 3, which would be negative 1. I'm going to do the same thing with 1. I'm going to put 1 in place of x. 1 in place of x, negative 2 times 1 is going to be negative 2 plus 3 is positive 1. And 0. 0 goes in place of x. 0 times negative 2 is 0 plus 3 is 3. So I have my x and my y table for the first piece. Okay. Now, I'm not going to look at the first piece. I'm now going to switch and I'm going to start looking at the second piece. The number that seems to show up in both is the number 3. So 3 is going to appear in my first table and 3 is also going to appear in my second table. So I'm going to now put 3, and I'm going to imagine on the number line, starting with 3 again. This time it says if x's are greater than or equal to 3. So I need numbers greater than 3. So I'm going to start with 3, and I'm going to do 4, 5, and 6. So these are going to be the numbers in my table, 3, 4, 5, and 6. All right, so this was just a number line just to kind of help us focus on where we were getting our x numbers from. I'm now going to put 3 into the second piece. It goes in place of the x. So I still have a 3. In place of the x is my new 3 minus 5. That's going to be 9 minus 5, so I'm going to get 4. I'm going to repeat the process with 4. If I put 4 in place of the x, 3 times 4 is 12. 12 minus 5 is 7. I can now put 5. 5 goes into the function. So I have 5. 5 times 3 is 15. Minus 5 is 10. The last one I think is going to be too big for our graph, but we'll go ahead and put it on our table anyway. 6. 6 times 3 is 18. Minus 5 is 15. No, 13. 13. All right, or 18 minus 5, which is 13. Those are my values. I'm now ready to put these on the graph. So here's what I'm going to do. This is a little bit messy, but of course I was trying to show you how you put your numbers and where they go so that you can get your values. I'm now going to graph these points. That's like the point 3, negative 3. So that's going to be like 3, comma, negative 3. So I'm going to go to 3, negative 3, and I'm going to put a point there. I'm going to use my blue pencil. Notice that this first piece on the 3 just says less than. So that's an open circle at 3, negative 3. Open circle. And I am making it bigger than you might would otherwise. I just want to make sure you see it. Positive 2, negative 1. positive 2, negative 1. That one could be a closed circle because the only time you have to do an open circle is on your line. Okay, 0, positive 1, and 0, 0, positive 1, and then I almost can't read my writing. What did I put in there? Let's see. Yeah, it was 1, 1, and 0, 3. 1, 1, and 0, 3. Yeah, just made it a little bit messy. So here's my line. It looks like this is a straight linear line, and of course this is a linear piece because it's x to the first power. And I know it's going to continue going up, up, up and to the left because it says all x is less than 3. I simply stopped at 0. I could have put negative 1 and it would have even higher. Could have went to negative 2 and it would have even higher. Negative 3, it would have went higher. So that's why I'm putting my arrow going up. Okay. Next, I'm going to graph my second piece of the function. Again, I'm starting with 3 again because 3 was in the table in both places. So 3, 4. This time I do see an equals on the 3. So at 3, 4, I'm going to put a closed circle. So over 3, up 4, closed circle. 4, 7. Okay. And then I'm going to go 5, 10. And I believe that's all I'm going to be able to put on here. This is also a linear piece. It's linear because, again, x is to the first power. Are there more numbers past 3 besides 6? Yes. So I know I can see enough of the pattern of the puzzle. I know it's going to go up that way. Now we're ready to determine which function do I evaluate at these points. So at negative 1, I come up here and I look at the function and I ask myself, do I look at the first piece or do I look at the second piece? And what I have to do is I have to look and realize this is an x. X is negative 1. That is a number less than 3. So for this particular part, I'm going to be actually doing the top piece. So negative 1, come up here, only go to the top piece. The only part that you ever substitute into is this first part. So it's going to be negative 2 times my negative 1 that I'm working with plus 3. All right, and that's going to be 5. Okay, so at negative 1, I should have 5. Okay, the function at 3. Let me see if I can erase all those big marks. Oops, didn't need to do that. Let's leave them on there and let's see if we can erase all these big marks. All right, I know I'm making it a little bit messy. I'm just trying to show you what I'm doing. All right, let's do f of 3. This time my x value is 3. So again, we're coming up here and we have to ask ourselves, is 3 less than 3? No, it's equal to 3. Right there's the equal. So I'm using this equation. So it's going to be 3 times the number x minus 5. And the number that I'm working with this time is 3. So 3 gets substituted in place. And 9 minus 5 is 4. Now the number is 5. The number is 5. And if I come back here and I ask myself which piece of the function do I go into? 5 is a number greater than 3. So I'm going to go to this piece. So it's 3 times my number minus 5 equals, and of course if I put 5 in here, that's 15 minus 5, which is 10. All right. So I've been able to evaluate my function at these different points. Now comes a question that's a little bit tricky sometimes, but I'm going to ask about domain. Now domain means that I have to consider, since this is a piecewise function, I have to consider what the entire domain is, both pieces combined. So when I look at this piece right here, and I know it comes up and goes to the left, if I will remember, that's actually going up to the positive infinity in the y direction. It's also going left to the negative infinity numbers in the x direction. Okay. This arrow up here is going right to the positive infinity numbers in the x direction, and it's going up to positive infinity in the y direction. Now, I want you to realize that as you come in here, you're going to come in here from the negative x's, because when you think about domain, you need to think about farthest to the left to farthest to the right. So I'm coming in here from the left, and as I come in here, I'm on these negative x's. I'm here, 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 up. It's like Mario's going to jump up here and keep going to the positive x's. Now, I may jump. I may have a gap that's vertical, but I still am using every single x. There's no x's left out, so that makes the domain, guess what? All real numbers. Okay, so the domain is all real numbers. You can use that big R, or you can say all real numbers. Now, what about the range? The range is from the lowest point on the graph to somewhere up here to the highest point on the graph. So you're going to kind of think about going up. What is the lowest point on the graph? The lowest point. Well, it doesn't touch at 10. It doesn't touch at 9, 8, 7. It looks like the first lowest point it touches is at -3. And there's an open circle at -3. So the lowest value I get to is -3. And then how high do we go? Well, if we look, we have arrows that are telling me that I'm going up in the y direction to positive infinity. So I can put infinity over here. There's a y in the middle. We know the signs for between goes backwards, backwards. It is not touching at -3, so I do not put an equals. Technically, this part is all you have to have, but if you were to tell me the entire sentence, I would give you full credit. Let's do the next one and we'll be done. All right, same kind of idea. First thing, highlight or mark on the x-axis by looking at your x's. So let's look at the x's. So if we look at the x's this time, what number seems to jump out at you? I hope that number is 4. So I'm going to come over here to the x-axis and I'll highlight this time. But I'm going to highlight on 4. Okay, whoops. I'm going to highlight on 4. If I use a colored pencil or an ink pen, I'll try to use a different color that I don't have easily, and I would be right here at 4. 4 is going to split it into 2 halves. Next thing I do is I'm going to find my x and y table. I want you to imagine, since 4 seems to be the number, I'm going to do an x and a y table for the first piece and an x and a y table for the second piece. I want you to imagine a number line and 4 in the middle. These are numbers less than 4. These are numbers greater than or equal to 4. So less than 4, I'm thinking about 3, 2, and 1. So I'm going to put 4 in here, and then I'm going to have 3, 2, and 1. Down here, if I think about numbers that are greater than 4, I'm going to put 4 in here. So I'm going to start at 4, and then I'm going to think about 2 or 3 numbers greater, so it'll be 5, 6, and maybe up to 7. And those are my x values I've chosen for this table. Okay, hopefully we've picked up by now that in order to get our x's or our y's, we take our x's and we put them in here. So 4 in parentheses, that's 4 minus 2, square the answer. So 4 minus 2 is 2, 2 squared is 4. Put 3 in here, do the same thing. 3 minus 2 is 1, 1 squared is 1. 2 minus 2 is 0, 0 squared is 0, and 1 minus 2 is -1, but -1 squared is negative times negative, which is +1. Okay, we now have our values for our top piece. Now let's get the values for our bottom piece. All right, the bottom piece, I'm going to start with 4. All right, so we're going to put 4. 4 goes into the bottom piece in place of x. So it's 2 times my 4 minus 4, which is 8 minus 4, which is 4. 5 goes into the same place. 2 minus 5 is 10. 10 minus 4 is 6. 6 times 2 is 12, minus 4 is 8, and 7 minus 2 is 14, minus 4 is 10. So I have my values for my x and y table for both pieces. I hope that if we discuss it and we look ahead at what we have, it looks like we have a piece up here that's x squared. So this is going to be quadratic, and I hope that you know that it's going to be a parabola. So I'm going to have at least a piece of a U-shaped graph. This one right here, though, is x to the first power, and x to the first power is linear. So I'm going to have a half of a parabola, or at least a piece of the parabola, and a piece of a line come together. Okay, let's graph the first points. I'm going to start with 4, 4, and notice that that point's on my line. Do I need to use an open circle or a closed circle at 4, 4? Okay, does not have an equals, so I need an open circle at 4, 4. So I'm going to come to 4, 4, open circle. Now, 3, 1, 2, 0, 1, 1. I actually think I can see where this is going. I know it's a U-shaped parabola, so I know it's going to come right here, and it's going to keep going up, up, up like that. That's enough of the graph for me to know what it looks like. Open circle right there. The next piece, 4, 4. This time when I do 4, 4, I'm actually going to have a equals, and because it's equals, I need a closed circle on 4, 4. Now, because I'm using a colored pencil or marker, you can actually distinguish the difference between where it was open and where it was closed. If you only use a pen or only use a marker, it's just going to look like one continuous line. So where the first piece came to, the second piece is picking it up and continuing from there. So I'm going to go 5, 6, 5, 6, 6, 8, and then 7, 10. I have a steep straight line and it's linear. So this side of the graph is quadratic. It is a parabola, or at least a piece of a parabola, and this side is linear. And they actually do meet right there. Find f of 0. Find f of 0. If x is my 0, I'm going to come up here and I'm going to make a decision. X is a number, 0 is a number less than 4, so I'm going to use the first piece. So it's going to be 0 minus 2 squared, which is going to be negative 2 squared. Now that's going to be negative times negative, which is positive 4. Okay, make sure that when you substitute in using parentheses and you won't mess up. Okay, all right, just cleaning up a little bit here. Almost done, almost done. F of 10. Okay, f of 10, remember that's my x. Do I use the first piece or do I use the second piece? Well, 10 is actually a number greater than 4, so I'm going to use the second piece. So it's going to be 2 times my number 10 in place of x minus 4, which is 20 minus 4, which is 16. Okay, next one is f of negative 1. Negative 1 is my x. If I come and I look, do I use the first piece or the second piece? First piece, negative 1 is a number less than 4. So for this one right here, I'm going to actually use the first one. I'm going to say in parentheses, negative 1 in place of x minus 2 and square the answer. That's going to give me negative 3, and negative 3 squared is negative times negative, which is positive 9. My domain, again, I have to do everything that I'm supposed to do. I need to realize this is going toward the negative infinity numbers in the x direction, and it's going to positive infinity numbers in the y direction. This arrow is going to positive infinity in the x direction and positive infinity in the y direction. Now, one more time, if you have arrows going in both directions, you have a what? All real numbers. Mario's going to come in here. It's going to keep going. So we're using all of our x's, both negative infinity to positive infinity, all real numbers. Okay. Now we still need to do our domain. Our range. So as our range, remember it's the lowest to the highest. So I'm going to start low on the graph. So when I start low on the graph, I'm asking, is 10 on my lowest? Nope. 9, 7, 6. Nope, nope, nope. What's the lowest number? Turns out the lowest value that it touches is what? 0. 0 is the lowest y number that's touched. So 0 is the lowest. How high does it go? Well, this arrow right here tells me that it's going up to what? Up to infinity. In both directions, it's going up to infinity. So the lowest it goes is 0. The highest it goes is up to infinity. And so infinity is going to be y in the middle, backwards, backwards. It does touch at 0. So we put it equals there. And as far as I'm concerned, that is good. You are actually telling me what it is. You only have to give the left-hand part, but that's it.